Hi everyone. Today we are going to talk about slopes and equations of lines. If you think back to Algebra 1, and remember, slope of a line is the ratio of the change along the y-axis to the change along the x-axis between any 2 points on a line. We also call it rise over run. We can also interpret it as a rate of change, which describes how a quantity y changes in relation to quantity x. So using any 2 points on a line, we can determine the slope of that line using the following formula. Okay, the difference in your y's over the difference in your x's. Let's try an example. Find the slope of the line using the points -1, -2, and 3, 3. Okay, it's very important that you label your points x1, y1, and x2 and y2. It doesn't matter which one is which, but you need to make sure you label it to keep your formula correct. Okay, so if I use the formula for slope, okay, and I'm going to plug in all of my points. I have 3, and watch your signs, it's minus a -2. And then at the bottom for our x's, we're going to have 3 minus a -1. Okay, so when we simplify this, subtracting a negative means we're adding a positive. Okay, so we're going to get 5 in our numerator, and our denominator is going to be 4. So the slope between those 2 points is 5 over 4. Okay, we can have different kinds of slopes. So if you think back to Algebra 1, you also did this in Algebra 2, you can have a slope with a positive upward trend. Okay, that will give us a positive slope. We can have a negative slope. Okay, so we have a negative downward trend from left to right. Okay, and the two others, okay, are the ones you don't see as often. Okay, they are having zero slope and an undefined slope. Let's talk about the slope of 0. So 0 slope, meaning there's no rise. Okay, so our line's not going anywhere. So if you think about it, a slope of 0 is just going to be a line that's horizontal. Okay, there is no rise, it is flat. Okay, but an undefined slope, okay, there's no slope. We can't define it. That's a vertical line. Okay, and if you think about it, there is no run to the line. So if we tried to calculate the slope, the denominator would be 0, and you can have any number, say 2 on the top. Can't do that. So that's why we have an undefined slope. Now, if we compare slopes of two separate lines, we can have parallel lines, we can have perpendicular lines, we can also have intersecting lines that don't intersect in any special way. Okay, if you have two parallel lines, they have the same slope or their slopes are equal. Okay, they will never ever intersect. They have a same rise and the same run. Okay, equal slopes. Now, slopes of perpendicular lines have opposite reciprocal slopes. So opposite meaning opposite signs. Reciprocal, you flip the fraction. So for example, if the slope of one line was -1 over 3, the slope of the line perpendicular to that line will be positive 3 over 1. So let's look at another example. Determine whether lines AB and CD are parallel, perpendicular, or neither, meaning they intersect in no special way. So I'm going to label my x1 and y1 for AB and figure out the slope. Okay, if I do y2 minus y1, I get 2 minus 6. And then my x's, I have negative 9 minus 3. That's going to give me negative 4 over negative 12. The two negatives cancel out, and when I reduce my fraction, I get a positive 1 over 3. Okay, now let's look at the slope of CD. I'm going to label my points x1 and y1, x2 and y2. Okay, so looking at my slope, 3 minus 4 is the difference in my y's, and the difference in my x's is 2 minus 5. Gives me a negative 1 in my numerator and a negative 3 in my denominator, but when I divide a negative by a negative, they cancel out, and I'm left with a positive 3 over 1 again. So since they have the exact same slope, we can say that lines AB and CD are parallel because they have the same slope. And that is all for today. See you next time, guys.